Hi and welcome to this video for the paper 2 2019. This is for question 1. So as always, if you want a copy of the set notes I'm working off, just send me an email at shanetroy@gmail.com. And I'd assume you've taken a pause and just try the question and then the answer's on the next page. Okay, so we'll get stuck in. This question 1 here, now part A and B are marked together and they're worth 10 marks. So it's a decent number of marks. It's statistics. So John measures the heights of 8 students in his class. Their heights in centimeters are given there. Okay. Now it's an, I suppose, unordered data list. Okay. Might be the smart to do is just first thing is just rearrange it to increasing size. Okay. Now we don't actually need that for this first part. We're just looking at the range where we get in the smallest. Actually, the R in increasing size. So it's 141, and the maximum is 172. Okay. So the range is maximum, take away minimum, and that's it. Okay, and let's go straight to the answer. Okay, so takes 172, take away 141. Now I would suggest always showing the calculation, even if it's an easy calculation. You probably even do it in your head, just in case you do make a mistake. And let's say you subtracted 172, take away 141, and you said 30. You had a brain, whatever. If they see wrong answer, no work shown, it's 0. Okay, whereas if you've shown the calculation, and even if you get it wrong, then you're going to have marks and potentially up to 4 marks for that would be just an arithmetic error. Okay, you've subtracted incorrectly. Okay. Now part B here, so write down which of these heights is an outlier. Okay. Now outlier means what's strange about it. Okay. So no, let's look at it. Okay, you think all these heights here are within what 5 and 2, 7 of each other. This is much smaller. So you've one person is much shorter than everybody else. So the answer is the 141 because it's different, much different than all the other ones. And if that was a study where you're collecting and measuring data, you might want to go, well, is there a problem with the measurement? Now, if that's a measurement of heights, as long as there wasn't a problem with the actual physical measurement of the student, it's just the heights of people go across a range. That's perfectly normal. Now, part C here says, work out the mean of the data. Okay. Now the mean of something, there's fancy formulas, okay, but basically it's add them all together, divide by the number of them. So if you add up all these numbers together, now I'm taking a screen grab of the original data, okay, so I'm adding all that, okay, that's done on top there. I'm dividing by the number of them, there was 8 of them, okay, and then put them through the calculator, I got 165.5, okay. Now I should always put this in part A and B, always put the units in, even if you don't need them technically for marks, and sometimes you don't, it depends on the marking scheme, just as a rule, always put them in. Okay, it's unfortunate to be losing marks here and there for such a small thing. Even if your calculator can do it, I would strongly suggest that you write this step here. You can always use the calculator to do it if that's what you're more comfortable with. But if you did program the calculator wrong and just showed your answer, and let's say you put in the wrong digit, you put in 176 instead of 167. Again, it's wrong answer, no work shown. Okay, and that's part C. Okay, part D here says, oh, I love words. John also measured the heights of the teachers in his school, and John makes a statement. Most of the teachers in my school have a height that is greater than 175 centimeters. Okay, put a tick in the correct box to show which of the following statements must be true. Okay, based on what John says. Tick one box only and give a reason for your answer. So the mean height of the teachers is greater than 175. Okay, the median height of the teachers is greater than 175, or the modal height of the teachers is greater than 175. Now it's worth pointing out here that mean, mode, and median are together described as the average in a mathematical sense. In slang or modern language, we would use the word average referring to the mean. Okay, but that's in a mathematical sense, that's not correct. So if you look at any set of data, the mean is just all the data added together divided by the number of them. So it can be misused, okay, especially when people refer to it as the average. And let's say you had everyone in a room was earning 20 grand a year, okay, and there was 10 people. The mean would be 20 grand. Add up all, divide by number 10, so it would work out. Imagine if some very rich person like Bill Gates or whatever walks in and he earns, just say, 20 billion a year, whatever. The mean would jump, and you could legitimately say the mean of everyone in this room is 20 million. Okay. So the mean salary of everyone in this room is 20 million. Now, there's 10 people, not including not Bill Gates, saying, I don't earn 20 million, I only earn 20,000. Okay. So the mean is it's just a number, and context matters. The median is when you add, you range all the data in an increasing size, and what's the middle data point. So it gives a much better understanding of the two sides. Okay, the mode is just the most common height. Okay, so in this sense, the median would make more sense. Okay, the reason, okay, is the mean can be influenced by very tall or short teachers. Okay, and the mode is simply sorry, my language here, is simply the most common height. Okay, so the mean could involve people who are like again very tall people could skew the mean. So the mean wouldn't be a good measure of that. Okay, and the mode again is just the most common height. Okay, right, that's D. Okay, so that's question one. So thanks very much, and see you on question two.